All right, so I think this is recording. Let's take a look at these three problems. They are quadratic equations, and they're asking us to solve these. If you look closely at each equation, you'll see that there's no x to the first term. There's no linear term on this. So by the directions, we can isolate the squared term and use the square root property. So let's go through these. For number one, we've got 5a squared. Let's add 40 to each side, and we have 45. Let's divide both sides by 5. Let's take the square root of each side. The square root of a squared is the absolute value of a. The principal square root of 9 is 3. This symbol means the positive square root of 9. And so then this equation gives us -3 or +3 as our two answers. With an exponent of 2, we were expecting two solutions, but they could be repeats. They could be repeated roots. Let's take a look at this problem number 2 and do it in a similar fashion. Let's take away x squared from each side. Let's add 12 to each side. Let's divide by 2. Take the square root of both sides. And oftentimes this step is, students don't show this step of the absolute value of x. They just jump straight to illustrating that x is positive or negative square root of 13 in this case. So you have two solutions if we write them out separately, or you could use the plus minus symbol and write it in shorthand notation. I'm still getting used to the software. I think I can shrink this up a little bit to give me some room. Yeah. Sometimes I can do that, and sometimes I cannot. All right. Same thing over here. Let's isolate. Let's solve for x squared. Subtract 24 from each side. Divide by 6. Take the square root of each side. And we see we have a problem here that the square root of -4 is not defined in the set of real numbers. Later, in a later skill packet, we talk about imaginary numbers, but for right now, we'll just say that there's no real solution. There's not a real number that when you multiply it times itself, you get a -4. Like I say, we will come in late at some later point and say that the square root of -4 is plus or minus 2i, where I is the imaginary unit. But you've seen it before, I'm sure, but we're going to look at it maybe in a little bit more detail, both this semester and in the second semester when we look at trigonometry. We look at complex numbers in a little bit more detail. Hey, I hope this helps, and I'll talk to you later.